Good morning. Today we are going to start a completely new unit. We're going to talk about rational expressions. This video today is about multiplying rational expressions, and the video will also go along with tomorrow's, which is dividing rational expressions. So you'll be able to use this video for both today and tomorrow's assignment. All right, so let's get started. The first thing that it's asking us to do is to simplify the following. Okay, what is simplify the following? If something can cancel out, I'm going to cancel it. So for example, right here, I have an x minus 5 in the numerator. I have an x minus 5 in the denominator. So I'm left in the numerator with an x plus 1. And in the denominator, I have an x squared minus 1. Now, if you remember, these right here is the difference in perfect squares. So I can go ahead and factor that. I have x plus 1 in the numerator. In the denominator, I have an x plus 1, x minus 1. When I factor the difference in perfect squares, x squared minus 1, it will factor into x plus 1, x minus 1. And if I were to multiply this back out, right here's what I would get, x squared minus 1. So I can simplify this further. I have an x plus 1 in the numerator, an x plus 1 in the denominator. I'm left with, in the numerator, there's nothing up there. So it's just a 1. In the denominator, x minus 1. So the moral of this is go ahead and factor as much as you can, then go ahead and simplify it. Let's look at this example. I have two quadratics, and if I factor these, x squared plus x minus 12, factors of 12 that will subtract and get me 1, okay, is 4 and 3. So I have a 4 and I have a 3, doesn't matter where they go. This tells me the signs are different. The largest one is going to be positive. So I have x plus 4, x minus 3. In the denominator, x squared plus 7x plus 12. Now I have factors of 12 that will add and get me 7. So that is still going to be 4 and 3. This tells me that both signs have to be the exact same. To get a positive 12 and multiply, they both have to be the same. This tells me what they both are. They're both positive. So now in the numerator, I have an x plus 4. In the denominator, an x plus 4. I cannot cancel these because they're very different. X plus 3 and an x minus 3. So that's my answer. You can put parentheses around these if you want to, but you don't have to. You can try A and B down here, and I'm going to do one of these down here, multiplying rational functions. When multiplying rational functions, you just multiply the numerators, multiply the denominators. So the simplest thing to do is to go ahead and factor everything completely, simplify as much as you can, and then just multiply straight across. So let's go ahead and factor this. X squared plus 2x minus 8. Factors of 8 that will subtract and get me 2. That is going to be 4 and 2. This tells me that the signs are different. The largest one is positive. So x minus 2 over x plus 4. In the denominator, I have an x squared plus 4x plus 3. Factors of 3 that are going to add and get me 4. 3 and 1. This tells me the signs are going to be the same. They're both positive. I'm multiplying this by 3x plus 3 over x minus 2. Neither one of these are quadratics, but in the numerator, I can factor out a 3, and I have x plus 1. 3 times x is 3x. 3 times 1 is 3. In the denominator, I just have an x minus 2. I can't do anything with that one. Now, I'm going to go ahead and see what I can simplify, what I can cancel out, and then just leave the answer. Here's an x minus 2. Here's an x minus 2. Here's an x plus 1. Here's an x plus 1. So in the numerator, I have an x plus 4. I also have a positive 3. I'm going to bring that out front. In the denominator, I have an x plus 3. And that's my answer. I cannot cancel these because 3 and an x plus 3 is very different. That's my answer. These can be any number except a negative 3. Remember, I cannot divide by a negative 3, so x cannot equal negative 3. I want to show you something else. Over here, x cannot equal a positive 2. Over here, x cannot equal a negative 1. So these are my restrictions. My restrictions, x cannot equal, and we could even go back to the original, x cannot equal a negative 3, a negative 1, or a positive 2. All of these would mean I would be dividing by 0. I'm going to let you do these. Tomorrow on your assignment is dividing rational expressions. So this is what your document will look like tomorrow. Dividing is the exact same thing as multiplying, okay? Except we need to remember your little keep, change, flip. Or, that's what you called it back in middle school, and that did not show up at all. But what you're going to do, you keep the numerator the same, okay? And what you're dividing by, you change the dividing by to a multiplication and flip it, the numerator and denominator. Okay, so you can see this one. I think you can do this one. I'm going to look at this one down here. This one looks awful scary, but it's not. So down here in example 2, I'm going to rewrite it, b squared over 25a squared minus b squared. And it is divided by b over 5 times the quantity a, 5a, minus b. Okay? So now what I'm going to do with this, I'm going to keep the first one the exact same. B squared over 25a squared minus b squared. I'm going to switch the sign from divide by to multiplication and then flip the last one. 5a minus b over b. At this point, I'm going to do the same procedure as I did yesterday. So I'm going to factor these as much as I can. I have a b squared. Okay, I can't do anything else with that one. Down here, these are the difference in perfect squares. So this is 5a plus b, 5a minus b. Okay, 25 is a perfect square, 5 times 5. A squared is a perfect square, a times a. B squared is a perfect square, b times b. 5a plus b, 5a minus b. Over here now, I cannot do anything with the 5a minus b and the b. But I'm going to cancel out. I have a 5a minus b in the numerator, a 5a minus b in the denominator. Down here, I have 1b, okay? And here I have 2. So I can cancel this and just make it a b to the first power. So my answer then, in the numerator, I have 1b to the first power, and in the denominator, I have 5a plus b. And there's my answer. I know that these are going to be confusing, so I will be here between 10 and 11 and 2 and 3 every day. So if you have any questions, I will see you then. Have a great day.